Hello, teacher. We will be doing our SADS project presentation with group members being Anson Pei, Ivan Chua, Aaron Choi, and Paco Chong. For the table of contents, we'll be doing first the introduction of topology, setup of services, DHCP, SSH router, and web server, and testing of services, which will test the services on a client virtual machine. So this is our topology diagram with the web server being sadspractical.com connected to a switch which is connected to the SSH server, which has DHCP as well, connected to network router and client PC.
So for the SSH server, we have the IP, which is 192.168.1.2. It consists of DHCP and SSH. So for SSH, we configured the firewall by adding the service SSH and uncomment edit parts like use PAM, login grace time, listening address, group permit, login, and etc. In SSH config, we added user student to the new group so that it will be the only user to access the SSH with root permits. We uncomment the parts in pam.d/2 to allow the usage of PAM and activation of it. And lastly, we boot up the SSH with sys. So for the DHCP, we edited the DHCPD.config with proper configuration on the left. And we edited the sysconfig DHCPD by booting DHCP dark, which is currently using the ENPOS3, and you will ignore the others if there is one by putting this. And now we set the correct permission for ownership for the DHCP lens in the library DHCPD. And lastly, we make a directory called DHCPD in run, and then we boot up the DHCP with syscon.
Okay, moving on to the router configuration steps. First, we set static IP and DNS on router's network interface NPOS3 using NMCLI. Then we enable IP forwarding in /etc sys.ctl.conf so that the router can pass traffic between networks. So IP forwarding allows the router to route traffic between interfaces such as from internal to external network. Then we configured firewall zones, assigning NPOS3 to public zone and assigning NPOS8 to internal zone. Then we enabled NAT and masquerading so internal devices can access the internet through the router. So what masquerading does is it allows internal devices with private IPs to access the external network using the router's public IP. Last but not least, we set firewall rules to accept forward traffic between internal and external network. And then we reload firewall to apply all changes. This ensures that traffic forwarding is allowed between zones. And the diagram below on the right shows how the router is in function, connected to the internet, and transferring the internet to the subnet of 192.168.1.0.
For the web server, we'll be using the DNS bind server with the domain www.sadspractical.com with the IP address of 192.168.1.4. The services that we'll be using is HTTPD, which is the same as Apache, named which runs the bind DNS server for forward and reverse lookups, firewall which allows DNS over UDP and TCP, which opens port 53 on our network, ensures that port 80 is open and prevents ping replies in the public network zone and network manager.
Onto the testing on the client VM. So for the DHCP, you can see that on the server side is enabled, and on the client side, we can receive the IP of 192.168.1.164 from the DHCP IP pool. And for the SSH, we can also see that it's enabled from the server side, and you can see the SSH server is 192.168.1.12, and the client, we can see that using student, we can SSH into the server. On the router, we can ping to 8.8.8.8 to see that it's working, and we can get a reply from the 8.8.8.8 itself. For the web, by going to www.sadspractical.com, you can access the web page showing on the left, and by doing the NS lookup, you can see the server IP of 192.168.1.4, and also ping the server itself, we can get a reply from it. So this is the role delegations assigned to each member in the group. Thank you. Now I'll be showing the demo of the testing of the services on the client VM. So first I'll be testing the DHCP to check that the client server can receive the IP from the DHCP server. By running inconfig, we can see that the client VM can receive the IP of 192.168.1.164 as shown as the picture just now. Next, we can use the IP of the SSH server of 192.168.1.2 and SSH in with the student user. And by inputting the password, we should enter into the SSH server. As you can see that the student user have the wheel group. This means that the student can change the user into root access, just like this, and we are in root. But if we use a different user that is not in the wheel group, like SSH test that we have created into the SSH server, as you can see, it's not in the wheel group. And if we try to bring ourselves into root access, permission should be denied. So that this shows that only selected user with the correct permissions can become root access. Now I'll be showing you the router to show that it's actually working. So first we'll be pinging the domain of 8.8.8, and we can see that we can receive replies from it. But if we were to turn down the router and pause it on the router itself, as you can see, I've turned it off on the router. If we go back to the client and try ping the same thing, it should show that destination host is unreachable. This shows that all services should be running on the router and not directly routed. So let me bring this back up. Now we're doing some NS lookup to check that this is actually working. So we first run on the router. As you can see, it's working on the SS server. And on the NS1, all should be working. So now onto the web. If we go into Firefox, if we go into the website www.sadspractical.com, it should show that the web server is working correctly. By going into the terminal again, if we do an NS lookup of the actual website itself, it should also return this. Further testing like pinging the web server can also show that it is working. So now this concludes my testing and demo of this services, and to show that everything is running by the router and all the services are working correctly. Thank you.